Welcome dear students. Let us start with the next video. Subject Geometry, Standard 10th, Chapter 6, Topic Trigonometry, Module 7. Let us see the objectives of this video. First, let us revise about the application of trigonometry and the concepts related to application of trigonometry. We are going to revise it. The concepts are: first, line of vision; second, angle of elevation; and third, angle of depression. And now, next thing we are going to see is we are going to solve the remaining problem set sums from problem set 6. Let us recall the formulas that we have seen in our last videos. So we had seen the trigonometric ratios. First is cot theta is equal to adjacent side upon opposite side. Cosec theta is equal to hypotenuse upon opposite side. Sec theta is equal to hypotenuse upon adjacent side. Next we had seen about the relation between trigonometric ratios. So first is cosec theta into sin theta is equal to 1. Sec theta into cos theta is equal to 1. Cot theta into tan theta is equal to 1. Also we had seen the formula of cot theta, that is cos theta upon sin theta. Next we did trigonometric identities or the trigonometric equations. So the three trigonometric equations which we have seen are sin square theta plus cos square theta is equal to 1. 1 plus cot square theta is equal to cosec square theta. 1 plus tan square theta is equal to sec square theta. Now let us see the concept of application of trigonometry. We have already seen some based on the application of trigonometry, and also we have seen certain concepts based on application of trigonometry. Let us revise these concepts over here as well. Let us learn some concepts before studying application of trigonometry. We have already seen these concepts in previous videos. Now let us revise it once more. So suppose there is a person who is looking at the building. If there is an object situated at point B, then from the observer, that is from the point A, there is a straight line that forms. That line is called as line of vision. So line of vision is basically the line which forms between the observer and the object. So if the observer is standing at location A, looking at an object at B, then line AB is called as line of vision. Now here in this picture, you can see that there is a person standing in front of a building. Wherever the object might be, on the top of the building or at some floor or below, wherever the object might be, still when a person he looks at that object, but the one line that forms from the eye of the observer, the line that goes straight, is nothing but horizontal line of vision, or also called as horizontal line. Now suppose the person is standing on the ground and he is looking at an object which is on the top of the building. So first of all, this will be the horizontal line. The line that goes straight is a horizontal line. Now when he is looking at an object situated upwards, so between the object and the observer or the person, the line that forms is line of vision. So between line of vision and horizontal line, there forms an angle over here. So this angle is nothing but angle of elevation. So angle of elevation is formed when we see above the horizontal line. So the definition of angle of elevation is: if the observer at A observes the point B which is at a level higher than A and AM is a horizontal line, then angle BAM is called as angle of elevation. Now suppose here the person is standing on the top of the building and he is looking at an object situated down or on the ground. So first of all, this is horizontal line. The line that goes straight is a horizontal line. But when he is looking down at an object, the line that forms between the object and the person or the observer is called as line of vision. So between the horizontal line and line of vision, there forms an angle. That angle is called as angle of depression. So basically, angle of depression is formed when the person is looking below the horizontal line. The definition of angle of depression is if the observer at A observes the point C, which is at a level lower than A, and AM is horizontal line, then angle MAC is called as angle of depression. So now we had seen or we have revised the concepts on application of trigonometry. Now let us move forward to the problems based on the application of trigonometry. Some problems we have already seen in our previous videos. Now the remaining sums we will do here. Problem set 6, question number 6. A boy standing at a distance of 48 meters from a building observes a top of the building and makes an angle of elevation of 30 degrees. Find the height of the building. So as you can see in this picture, a person is standing or a boy is standing at some distance away from the building. The distance is 48 meters and he is looking at the top of the building, which means he is making an angle of elevation. So angle of elevation is given, that is 30 degrees. So he is making an angle of elevation of 30 degrees and we need to find the height of this building. So let us see how we are going to find the height of this building. So now first of all let us formulate this problem in the form of diagram. So AB is nothing but height of the building. CB or BC is equal to 48 meters, which is distance of the observer from the building. So BC is equal to 48 meters. AC is nothing but line of vision. So the observer is at C and the object is at A. So AC is nothing but line of vision. So between the line of vision and horizontal line, then there forms an angle of elevation which is 30 degrees. So therefore angle BCA or ACB is equal to 30 degrees, which is equal to angle of elevation. So now we are going to use tan ratio because here we have adjacent side. In this triangle ABC we have adjacent side and we need to find out the opposite side, which is AB, that is height of the building. So we are going to use tan ratio. So tan theta is nothing but opposite upon adjacent, so which is equal to AB upon CB. So now the value of CB we already know and the value of theta is 30 degrees. So we know tan 30 degrees. So let us consider tan theta is equal to AB upon CB as equation 1 and tan 30 degrees is equal to 1 upon root 3 as equation 2. So from equation 1 and 2 we get AB upon CB is equal to 1 upon root 3. Therefore AB is equal to CB upon root 3, which is equal to 48 upon root 3. 48 is nothing but the value of the distance of a boy from the building, which is given in the question. So now further we can solve it and we can multiply by root 3 in numerator and denominator so that we can get rid of root 3 in the denominator. So therefore we will get AB is equal to 48 into root 3 upon root 3 into root 3, which is equal to 48 into root 3 upon 3. Therefore we get AB is equal to 16 root 3. So hence we get the answer of the height of the building as 16 root 3. Therefore the height of the building is equal to 16 root 3 meters. Now let us see the seventh question. Two buildings are in front of each other on a road of width 15 meters. From the top of the first building, having the height of 12 meter, the angle of elevation of the top of the second building is 30 degrees. What is the height of the second building? Again, this is similar type of question which we have seen previously. So let AB and CD represent the height of two buildings on either sides of road. So suppose this is AB and this is CD, which are two buildings which are facing each other and are situated on either side of the road. Let BD be the road or the width of the road, which is 15 meters. So AB is 12 meters given and BD is 15 meters. Now let us draw a horizontal line AE. Let AC be the line of vision. So between line of vision AC and horizontal line AE, there forms an angle of elevation which is made on the top of the second building, which is 30 degrees. So angle of elevation made is 30 degrees. So let angle CAE is the angle of elevation. Therefore angle CAE is equal to 30 degrees. Now we can see that quadrilateral ABDE is a rectangle, which is by definition. So we can say that opposite sides of rectangles are same. So therefore AB is equal to DE, which is equal to 12 meters. AE is equal to BD is equal to 15 meters. So now let us consider triangle AEC. So in triangle AEC, angle AEC is equal to 90 degrees. So therefore tan of angle CAE is equal to CE upon AE. So therefore tan of 30 is equal to CE upon 15. Now the value of tan 30 we already know from the table, which is 1 upon root 3. So let us substitute it over here. So therefore we get 1 upon root 3 is equal to CE upon 15. So therefore CE is equal to 15 upon root 3. Now in the denominator, always don't keep the value as root 3. So we can multiply in the numerator and denominator both by root 3's. So we get 15 into root 3 upon 15 upon root 3 into root 3. So therefore CE is equal to 15 root 3 upon 3. Now 3 ones are 3 and 3 5s are 15. So we can cancel the numerator part and the denominator part and we get the value of CE is equal to 5 root 3. So CE is nothing but the half value. Now we know that CD is equal to CE plus DE because points C, E and D are collinear. So now the value of CE we have found out, which is 5 root 3, and the value of DE we already know as 12 because it is the opposite side of a rectangle, which is AB. So opposite side of DE is AB. The value of AB we already know, that is 12 meters. So the value of DE will also be 12 meters. So after adding it, we will get the exact value. Now here the value of root 3 is not given in the question. So if it is not given in the question, there is no need to substitute it. We can directly keep our answer as it is. So therefore the height of the second building is 12 plus 5 root 3 meters. This is our final value. Eighth question from problem set. The question says, from the top of the lighthouse, an observer looks at the ship and finds the angle of depression to be 30 degrees. If the height of the lighthouse is 100 meters, then find how far the ship is from the lighthouse. So here there is a lighthouse which is 100 meters tall and there is a ship in the sea. There is a person on the top of the lighthouse and he is looking at the ship. When he is looking at the ship, he is making an angle of depression which is 30 degrees. They have asked us to find the distance of the ship from the lighthouse. Now let us formulate this sum in the form of diagrammatic representation. So here AB is the height of the lighthouse, which is 100 meters. C represents the ship and A is the position of the observer. So here C, it represents the ship. So BC is nothing but distance of the ship from the lighthouse. AC is nothing but line of vision. So A is basically the position of observer and observer is observing an object which is situated at C. So AC is the line of vision. AM is the horizontal line and angle MAC is angle of depression. So angle of depression that is given in the question is 30 degrees. Now we know that angle MAC and angle ACB are alternate angles. So therefore we can say that angle MAC is equal to angle ACB, which is equal to 30 degrees because they are alternate angles. So by alternate angles theorem, angle MAC is equal to angle ACB. Now let us consider triangle ABC. So in triangle ABC, angle ABC is 90 degrees because lighthouse is perpendicular to the ground. So now opposite side in this triangle, opposite side is nothing but height of the lighthouse which is given, and we need to find out the distance of the ship from the lighthouse, which is adjacent side. So we are going to use tan ratio. So tan of angle ACB is equal to AB upon BC. So therefore tan of 30 degrees is equal to AB upon BC. Now let us substitute the value of tan 30 degree from the table and the value of AB which is given from the question. So therefore 1 upon root 3 is equal to 100 upon BC. Therefore BC is equal to 100 root 3. So BC is nothing but the distance of the ship from the lighthouse. So hence we get the distance of the ship from the lighthouse is 100 root 3. Now the ninth question is, a ladder on the platform of a fire brigade van can be evaluated at an angle of 70 degrees to the maximum. The length of the ladder can be extended up to 20 meters. If the platform is 2 meters above the ground, find the maximum height from the ground up to which the ladder can reach. So here in the question they have given that there is a fire brigade van and from the platform of a fire brigade van there is a ladder which is evaluated at an angle of 70 degrees to the maximum height. The length of the ladder can be extended up to 20 meters. So the length of the ladder is given, that is 20 meters. Now the platform is 2 meters above the ground. So we have to find the maximum height from the ground up to which the ladder can reach. Also they have given the value of sin 70 as 0.94. So in the solution, let us construct the diagram first. So GD is a ground level. Suppose GD is ground level. BC is the base of the ladder of the fire brigade van at a height of 2 meters from the ground level. T is suppose the top of a ladder of the fire brigade van at the maximum height. Angle TBC is equal to 70 degrees, which is nothing but angle of elevation. BT is the length of the ladder. Suppose BT is the length of the ladder, which is 20 meters. BG is equal to 2 meters. So you can see that quadrilateral BGDC is a rectangle, which is by definition. So we know that BG is equal to CD, which are opposite sides of rectangle, so they are equal. The value of BG is 2 meters, so therefore the value of CD will also be 2 meters. Now let us consider triangle TBC. or BCT. So in triangle BCT, angle BCT is equal to 90 degrees. So now we have the value of hypotenuse side in this triangle, triangle BTC. We have the value of hypotenuse side which is 20 meters. So we can use the value sin theta because we want to find the opposite side which is TC. So of angle 70 degree we want to find opposite side. We have the hypotenuse side, so we can use the trigonometric ratio of sine. So sine of angle TBC is equal to opposite upon hypotenuse, which is equal to TC upon TB. So tan of angle TBC is nothing but sine of angle TBC is nothing but sine 70 degrees. So therefore sine 70 is equal to TC upon 20. So therefore 0.94 is equal to TC upon 20. Therefore TC is equal to 0.94 into 20. So therefore TC is equal to 18.80 meters. So we got half height. Now we have the remaining half height, that is DC. So by adding TC and DC, we will get the entire value, that is TD. So therefore TD is equal to TC plus CD because TC and D are collinear. So therefore TD is equal to 18.80 plus 2. Therefore by adding these two values, we get the value of TD as 20.80 meters. So therefore the other side or the other end of the ladder can reach 20.80 meters above the ground. The last sum of application of trigonometry, that is the 10th sum. Let us see how to solve this sum. While landing at an airport, a pilot made an angle of depression of 20 degrees. Average speed of the plane was 200 km per hour. The plane reached the ground after 54 seconds. Find the height at which plane was when it started landing. So let us formulate this question in the form of diagram so that it will be easier for you to understand it and then solve it. So suppose A represents the position of the plane above the ground. So A is the position of the plane at some height above the ground. Suppose C is the landing point of the plane on the ground. AB represents the height of the plane from the ground. Angle DAC is the angle of depression. So angle DAC will be equal to angle ACB because they are alternate angles. So if angle DAC is given as 20 degrees, then angle ACB will be also 20 degrees. So now first of all let us find out the value of AC, that is distance covered by the plane from its actual position to its landing position. So which is AC. So AC is equal to speed into time. Speed is also given and time is also given. So speed is given as 200 km per hour and time is given as 54 seconds. So first let us convert this 54 seconds into hour so that we can find out the distance in the form of kilometer, because speed is given in the form of kilometer per hour and time is given in the form of seconds. So first we need to convert this time in the form of hour. So we get 200 km per hour into 54 upon 3600 hour, because we know that 1 hour is 3600 seconds. So 54 seconds will be 54 upon 3600 hour. So now let us multiply these two terms. We get 3 kilometers. After multiplying it, we get 3 kilometers. So therefore the distance, that is AC, is equal to 3 kilometers. Now let us convert this AC in the form of meters. So we know that 1 kilometer is equal to 1000 meters. So therefore 3 kilometers will be 3000 meters. So therefore we get the value of AC, that is distance of the plane from its actual position to its landing position, as 3000 meters. Now we need to find out the height at which plane was when it started landing. So let us find out this. Now let us see that in this triangle ABC, angle ABC is equal to 90 degrees. So therefore, we need to find out the value of AB. So we are going to use sine ratio because we have hypotenuse side in this triangle and we need to find the opposite side. So we are going to use sine ratio. So sine of angle ACB is equal to AB upon AC. This is by definition. Now angle of ACB we know that is 20 degrees. So let us substitute it over here. So we get sine of 20 is equal to AB upon 3000. Value of sine 20 is given, that is 0.342. So substituting it we get 0.342 is equal to AB upon 3000. So now let us multiply these terms. We get AB is equal to 0.342 into 3000. So AB is equal to 1026 kilometers. One 1026 meters. So therefore the plane was at a height of 1026 meters when it started landing. So hence we get the value of AB as 1026 meters. So I hope you all have understood today's video. The next sums we will be solving in our next lecture. Thank you.